The introduction. My topic is about vanadium diselenide, whose formula is VSE2. Today I'm going to share some facts about the structure and composition of vanadium diselenide and its application. Vanadium diselenide is used in a variety of things. For instance, it is widely used in semiconductors and metals. It has implication in 2D crystals. Vanadium diselenide has a complex structure. It is a layered material, which means that it is a layered transmission. Decalcigenide, while crystallization it makes from 1T-CdL2. Its properties as two-dimensional conductors diverse. Vanadium diselenide has got some interesting physical properties that range from the rare, astonishing Raman spectra and electrical conductivity. Vanadium diselenide primarily belongs to selenide class, which formula weight 208.861. Vanadium diselenide is composed of element V and Se, where V has 24.39 proportion and Se has 75.61 composition.
Vanadium diselenide is a typical layered semimetal, TMDC, which stands for transition metal dichalcogen. At first it was thought to be difficult to synthesize until there was a change in concentration of the precursors and the reaction steps in hydrothermal methods. There are three types of this material. The first is nanohydrangea, the second is nanodandelion, and the last is hexagonal discs. The first two are polycrystalline, and the hexagonal discs are single crystal structures. Each of the three shapes shows differences in intrinsic properties, mostly represented by differences in nitrogen absorption and desorption, and differences in UV visual absorption analysis. Vanadium diselenide can be drawn into hexagonal discs, stabilized through annealing. Semiconductor properties allow it to be used as buffer sheets in cadmium telluride solar cells. They increase overall cell performance by acting as p-type semiconductors. This semiconductor has a high work function and a high carrier concentration.
Vanadium diselenide has some very interesting properties. One of its most interesting properties is called photocatalytic mechanisms. It's very different from the rest of the semiconductors. Photocatalytic prevents vanadium diselenide from self-decomposing since it goes under risk conditions. This makes it more effective than the other semiconductors. We learned that vanadium diselenide is best used for the efficiency of a semiconductor. We found out that vanadium diselenide has been shaped into three types of structures. 1. Nanohydrangea, 2. Nanodandelion, 3. Hexagonal disc. For the most noticeable, hexagonal disc has been used into an ultra-thin nanosheet, which helps more efficiently create the solar cells work more efficient. We know that vanadium diselenide major key factor is that it should stay stabilized, since it begins to destroy itself. But thanks to photocatalytic, it helps prevent the decomposing of itself. Vanadium diselenide is a very interesting element that took several years to synthesize, but now has made other mechanisms more efficient. This concludes our presentation. Thank you for watching.